The human brain is not a solitary machine, but a responsive instrument constantly tuned to those around us. This invisible tether shapes nearly every thought you have ever had. Neuroscientists have discovered that the brain's default setting is actually social processing. As we settle in to explore these relaxing facts for sleep, taking a quiet moment to subscribe or like this collection helps us stay connected too. When you stop focusing on a specific task, your brain does not simply power down or go blank. Instead, it immediately switches on a specific circuit dedicated to thinking about other people, their intentions, and your relationship to them. This neural pathway is known as the default mode network. It activates the instant you finish a math problem or complete a logical puzzle, snapping your focus back to social thoughts like a rubber band. Evolution seemingly wagered that understanding your peers was more critical for survival than understanding the physical environment. This biological priority is why human beings have such a disproportionately large neocortex compared to other mammals. The social brain hypothesis suggests that our intelligence expanded primarily to handle the complexities of living in large, complex groups. There is, however, a theoretical limit to how many of these connections you can maintain. Anthropologist Robin Dunbar calculated that the human brain can only comfortably manage about 150 stable relationships at any given time. Beyond this number, the cognitive load becomes too heavy to track who trusts whom. This limitation remains consistent from ancient hunter-gatherer villages to modern military units and even digital social networks. The need for this connection is not merely psychological, but deeply physical. Biology treats social isolation as a direct threat to survival. The feeling of loneliness triggers the exact same areas of the brain that process physical pain. When you feel rejected, the anterior cingulate cortex activates just as it would if you had stubbed your toe or burned your hand. This is why social exclusion hurts in a literal neural sense. Your body responds to the presence of others even when you are not speaking. The vagus nerve, which wanders from your brainstem down to your abdomen, acts as a primary highway for the social engagement system. It slows your heart rate and promotes digestion when you hear a soothing, familiar voice. This physiological link explains why holding the hand of a loved one can instantly lower blood pressure and reduce the perception of physical pain. The brain is so eager for connection that it uses temperature as a proxy for trust. Psychological studies have shown that physically holding a warm cup of coffee makes you perceive strangers as having warmer personalities. Conversely, holding something cold leads people to judge others as more distant or selfish. This overlap happens because the insula, a part of the brain tucked deep inside the cerebral cortex, processes both physical temperature and psychological warmth. We are wired to seek heat and company in equal measure. Even your brain waves seek to align with those around you. When two people are deeply engaged in conversation, their neural activity begins to synchronize. This phenomenon, known as neural coupling, means the listener's brain activity mirrors the speaker's with a slight delay. In moments of high understanding, the listener's brain can even anticipate the speaker's neural patterns before they finish their sentence. This deep synchronization creates a shared reality where two minds temporarily function as a single unit. This unified mental state is not merely a conversational quirk, but the very reason your brain exists in its current form. If you look at the sheer biological expense of the human brain, a startling pattern emerges that points directly to the necessity of connection. Your brain represents only about 2% of your total body weight, yet it consumes roughly 20% of your daily energy intake. This is a massive metabolic tax, a heavy price that nature would not pay without a return on investment that was absolutely critical for survival. For decades, scientists assumed this energy was spent on ecological problem solving, such as mapping territories, remembering where fruit trees bloom, or figuring out how to crack open nuts with stones. While these skills were certainly useful, they do not fully account for the explosive growth of the neocortex, the unwrinkled outer layer of the brain responsible for higher-order thinking. The leading explanation for this rapid expansion is known as the social brain hypothesis. It proposes that the primary driver of human intelligence was not the need to master the physical environment, but the need to master the complex, shifting, and often treacherous landscape of the social group. The physical world is governed by consistent laws. A rock will always be a rock, and gravity will always pull it down. The social world, however, is dynamic and unpredictable. To survive in a tribe, an early human had to track not just their own relationships, but the relationships of everyone else around them. You had to know who was allied with whom, who was currently feuding, who held status, and who was likely to betray the group. Keeping a mental ledger of these third-party relationships requires a staggering amount of computing power. When researchers compare the brain sizes of various primates, they find a direct correlation between the volume of the neocortex and the average size of the social group that species maintains. Lemurs, with smaller brains, live in small, simple clusters. Chimpanzees, with larger brains, navigate more complex political hierarchies. Humans sit at the extreme end of this spectrum, with a brain volume designed to manage a social network of approximately 150 distinct individuals. In primate societies, social bonding is maintained through physical grooming, a time-consuming process of picking through fur that releases bonding hormones like oxytocin. As human groups grew larger, there simply were not enough hours in the day to physically groom every ally needed for safety. This evolutionary pressure likely drove the development of language, which some anthropologists describe as vocal grooming. By talking, we can service the emotional needs of several people at once, maintain bonds from a distance, and even connect in the dark. We traded the intimacy of touch for the efficiency of speech, allowing us to sustain the large cooperative groups that kept us alive. This reliance on the group was total. Unlike other predators, humans lack sharp claws, protective fur, or overwhelming speed. An isolated human on the ancestral savanna was not a survivor, they were a casualty. Therefore, the brain evolved to treat social isolation as a threat as severe as thirst or injury. This deep-seated wiring means your nervous system is perpetually tuned to the presence of others, reacting to social signals with immediate physiological changes that ripple through your entire body. This ripple effect is nowhere more undeniable than in the experience of rejection. When you say your feelings are hurt or that a situation was painful, you are not using a metaphor. You are offering a precise biological description of what is happening inside your skull. Neuroscientists using fMRI technology have observed that when a person experiences social exclusion, even something as simple as being left out of a digital ball-tossing game, the brain activates the dorsal anterior cingulate cortex. This is the exact same neural region that lights up when you spill hot coffee on your hand or stub your toe. To your brain, the distress of a broken heart and the distress of a broken bone share the same neural alarm system. There is a grim evolutionary logic to this shared circuitry. In our ancient past, being cast out of the tribe was essentially a death sentence. A lone human on the savanna could not hunt effectively, defend against predators, or survive illness. Therefore, nature could not afford for you to be merely annoyed by isolation. It had to feel catastrophic. By hijacking the pain system, evolution ensured that social rejection would be just as urgent and impossible to ignore as physical injury, compelling you to immediately correct your behavior and reintegrate with the group to ensure your survival. This biological overlap is so precise that it has led to some startling experiments regarding common painkillers. In a study conducted at the University of Kentucky, researchers found that acetaminophen, the active ingredient in Tylenol, could actually reduce the intensity of hurt feelings. Participants who took the painkiller daily for 3 weeks reported significantly fewer hurt feelings in their social interactions compared to those taking a placebo. Furthermore, when these participants were placed in an MRI scanner and subjected to social exclusion, their brains showed significantly less activity in the pain processing regions. It suggests that because the brain piggybacked social needs onto physical pathways, the mechanisms we use to numb a headache can inadvertently numb the sting of a social slight. The physical reality of rejection extends beyond the brain and into the regulation of your body temperature. We often use idioms like receiving a cold shoulder or a warm reception, but these phrases are rooted in physiological truth. Experiments have demonstrated that when people recall a time they were rejected or feel currently excluded, their skin temperature actually drops. In one study, participants who were excluded estimated the temperature of the room to be significantly colder than those who were included. This psychological chill drives a behavioral response, leading excluded individuals to crave warm foods and hot drinks in a subconscious attempt to self-soothe. Have you ever noticed that you tend to reach for coffee, tea, or warm soups when you are feeling lonely or down? It is likely your body's way of trying to replace the warmth it expected to receive from social contact. This thermoregulatory response happens because for our ancestors, separation from the group meant the loss of shared body heat, prompting the body to constrict blood vessels and preserve core temperature, a survival reflex triggered by the mere feeling of being alone. This deep-seated link between our physiology and our social surroundings is mirrored in the very architecture of the brain itself, specifically in a system known as the default mode network. For decades, neuroscientists operated under a logical but ultimately incorrect assumption about how the brain functions during downtime. The prevailing belief was that when you stop focusing on a specific task, when you stop solving a math problem, reading a sentence, or navigating a busy street, your brain simply goes quiet, reducing its electrical activity to save energy, much like a car engine idling at a stoplight. However, in the early years of the 21st century, researchers analyzing brain imaging scans noticed something peculiar. When participants in these studies were asked to simply rest and let their minds wander, a specific network of brain regions did not power down. Instead, it lit up with intense, synchronized activity. This network became known as the default mode network, or DMN, because it is the state the brain reverts to the moment it is not engaged in an external task. The most fascinating discovery was not just that this network exists, but what it actually does with its processing power. When the brain is left to its own devices, it does not default to thinking about physics or geography or the mechanical workings of the universe. It defaults to thinking about other people. The default mode network is, for all intents and purposes, the brain's social processor. It is anatomically anchored in the medial prefrontal cortex, a region located roughly behind the middle of your forehead. This area is famously associated with social cognition, the ability to understand yourself and interpret the thoughts, feelings, and intentions of those around you. There is a neurological antagonism at play here, often described as a seesaw mechanism. When you are engaged in a non-social analytical task, the social brain is suppressed to allow for focus. But the second that task is finished, literally the moment you stop concentrating, the seesaw tips back and the social brain reactivates. Neuroscientist Matthew Lieberman describes this mechanism as a reflex. Just as your leg kicks out when a doctor taps your knee, your brain switches on its social radar the instant it is free from other obligations. This suggests that evolution placed a higher premium on social intelligence than on general problem solving. In the ancestral environment, knowing who was angry with you, who was allied with whom, and what your peers were planning was the single most critical factor for survival. Therefore, nature designed the brain to use its spare moments to practice social scenarios, replaying past conversations and simulating future interactions to keep your social skills sharp. The energy cost of this constant social vigilance is staggering. Despite making up only about 2% of the body's total energy intake, the brain consumes roughly 20% of the body's total energy intake. A significant portion of that metabolic budget is dedicated not to moving muscles or processing sensory data, but to maintaining this internal model of the social world. We are quite literally burning calories to hallucinate the minds of others, running complex simulations of their perspectives even when they are not in the room. This biological investment indicates that for the human animal, understanding the group is as vital as breathing. We possess high-powered hardware specifically engineered to navigate the complexities of community, yet even this sophisticated biological machinery has its constraints, leading us from the limitless potential of brain anatomy to the hard boundaries of our cognitive software. This specific boundary was identified by anthropologist Robin Dunbar, who discovered a distinct mathematical ratio between the size of a primate's neocortex and the size of the groups they formed. The neocortex is the wrinkled outer layer of the brain responsible for conscious thought, sensory perception, and language, and essentially it acts as the limiting factor on our social hard drive. For humans, given our specific brain volume, that hard limit settles at approximately 150 individuals. This number, 150, represents the maximum number of stable relationships you can maintain at any given time, generally defined as knowing exactly who a person is and how they relate to every other person in your network. But within that maximum capacity, our social world is not a uniform crowd. It is structured like the concentric rings of an onion, with each layer determined by emotional closeness and the frequency of contact. At the very center sit roughly 5 people, often called the support clique, who essentially receive about 40% of your total social time and emotional energy. Stepping outward, the next ring contains about 15 people, your sympathy group, encompassing the close friends and family members you might rely on for regular care or daily support, the ones whose loss would significantly impact your life. Beyond them lies a circle of 50, often regarded as your main sphere of friends, the people you would invite to a large party or a group dinner. The reason these numbers remain so consistent across cultures is that relationships are not passive. They are biologically expensive, requiring significant memory processing to track dynamic alliances, changing moods, and social debts. The brain must compute not just your relationship to one person and your relationship to another, but also understand the fluctuating relationship between those two people, a computational task that grows exponentially with every new individual added to the web. History seemingly adheres to this biological rule with uncanny precision, as census data from hunter-gatherer societies to 18th century English villages reveals an average community size hovering near that 150 mark. Modern military organizations have intuitively respected this limit for centuries, organizing basic fighting units like the company around 150 soldiers. At this specific scale, orders can be maintained through personal loyalty, trust, and peer pressure. But once a group exceeds this number, it requires formal regulations, rigid ranks, and impersonal bureaucracy to function effectively. Hutterite farming communities in North America famously apply this logic by splitting their colonies into 2 separate settlements, precisely when they reach 150 members. Their tradition holds that once the group exceeds this number, the community ceases to be a partnership of neighbors and becomes a society of strangers, requiring a police force rather than social pressure to maintain peace. Even in the age of digital connectivity, where online friend counts can easily reach the thousands, studies indicate that our genuine two-way interactions rarely break through this ancient biological ceiling, proving that while our technology scales infinitely, our capacity for connection remains tethered to the architecture of the mind. Deep within that architecture lies a specific network of cells that dissolves the barrier between you and the person standing across from you. This discovery, arguably one of the most profound shifts in modern neuroscience, occurred not by grand design, but through a happy accident in a laboratory in Parma, Italy, during the early 1990s. A team of researchers led by Giacomo Rizzolatti was monitoring the brain activity of macaque monkeys, specifically focusing on the premotor cortex, the area responsible for planning movements. They had placed delicate electrodes to track individual neurons that fired when a monkey performed a specific action, like grasping a piece of fruit. The story goes that during a break, a researcher reached out to grab a raisin or perhaps a nut, while the monkey simply watched. To everyone's astonishment, the audio monitor connected to the monkey's brain erupted with the crackling sound of neurons firing. The monkey had not moved a muscle, yet its brain was reacting exactly as if it were the one reaching for the food. This accidental observation unveiled what we now call the mirror neuron system. Before this moment, neuroscientists largely believed that the brain possessed distinct, separate channels for perception and action, that seeing was one thing and doing was entirely another. The mirror neuron shattered this divide, suggesting that to the human mind, watching an action and performing it share the same neural blueprint. When you watch a high-wire artist stumble, your own stomach drops and your muscles tense because your brain is running a silent simulation of the fall. You do not merely observe the world, you physically rehearse it in the theater of your own mind. This internal mirroring is widely believed to be the biological foundation of empathy, the mechanism that allows us to look at a face contorted in sorrow and instantly feel a shadow of that same grief. It's a form of emotional data transfer, a hardware setup that forces us to experience a simulation of the lives surrounding us. However, as this concept migrated from the laboratory to the general public, it became wrapped in a layer of mythology that requires careful peeling. Popular psychology often paints mirror neurons as magical empathy switches that automatically generate compassion, but the reality is far more intricate and functional. These neurons are primarily concerned with intention and prediction. They do not just copy the movement, they try to decipher the reasoning behind it. If you see a hand reaching for a cup, your mirror system instantly calculates whether the intent is to take a sip or to clear the table, based on subtle contextual clues. It is less about mystical telepathy and more about rapid subconscious hypothesis testing, allowing us to navigate complex social environments by predicting what others will do fractions of a second before they do it. This predictive power turns observation into a form of learning. It is how an infant learns to smile by watching a parent, or how an apprentice learns a craft by watching a master, absorbing the rhythm of the movement before their own hands ever touch the tools. This existence of this system suggests that we are biologically wired for connection, not just through language, but through a shared motor resonance. We are constantly, silently mimicking the posture, breathing, and micro-expressions of those we trust, a phenomenon that bridges the gap between individual nervous systems and creates a synchronized social reality. This deep synchronization finds its most specific physical channel in the anatomy of the human eye itself. Unlike nearly any other primate, humans possess a highly visible white sclera surrounding the colored iris. In the animal kingdom, most eyes are dark or camouflaged to conceal the direction of the gaze, a protective measure that prevents predators or prey from predicting a creature's next move. We, however, evolved the opposite trait. The brightness of the human sclera creates high contrast, making the direction of our eyes immediately readable to others. This feature, known as the cooperative eye hypothesis, suggests that our eyes evolved not to hide our thoughts, but to broadcast them, facilitating the kind of complex joint attention required for human society to function. Before a human infant can understand language, they can track the movement of a parent's eyes against the white background, a skill that chimpanzees do not naturally possess. This visibility sets the stage for the eye contact effect, a phenomenon where the mere act of meeting another's gaze grabs the brain's attention faster than any other visual stimulus. It's a privileged signal. When you lock eyes with someone, the arousal centers of your brain, including the amygdala, light up within milliseconds, prioritizing this interaction above all else. This process is so cognitively demanding that it can actually disrupt your working memory. If you have ever felt the need to look away to remember a complex fact or perform a difficult calculation, it is because maintaining eye contact consumes the same neural bandwidth required for intense cognitive processing. The old adage that the eyes are the window to the soul is actually a biological reality, as the eyes are the only part of the brain that is visible from outside the skull. Within the colored iris, the pupil acts as a subtle, often subconscious signal of this social connection. While we know pupils adjust to light, they also dilate in response to interest, attraction, and emotional arousal. We are biologically programmed to detect this change in others. Studies show that we perceive faces with dilated pupils as friendlier and more attractive, often without realizing why. This leads to a phenomenon known as pupillary contagion. When we interact with someone we trust, our pupil size will often adjust to match theirs, a microscopic dance of the autonomic nervous system that fosters emotional alignment. The impact of this connection goes deeper than simple signaling. Neuroscientists, using hyperscanning technology, scanning two brains simultaneously, have observed that mutual gaze causes a synchronization of brainwave patterns between two people. When eye contact is made, the right inferior frontal gyrus in both brains begins to fire in the same rhythm. This neural coupling does not happen when looking at a video or a picture. It requires the real-time awareness that another mind is looking back. It suggests that eye contact is the physical mechanism that dissolves the barrier between solitary minds, creating a temporary shared neural loop where two nervous systems regulate each other. This intense connection is the bedrock of self-consciousness. It explains why the mere realization that you are being observed can trigger a sudden, uncontrollable rush of heat to your cheeks. Before we unravel the biology of that heat, I wonder if you have a memory of a time when you felt the weight of a room's attention shift entirely to you. Perhaps a moment where you felt exposed or truly seen, and how your body reacted before your mind could even process the event. Feel free to share that experience in the comments. That involuntary flush is, scientifically speaking, a biological singularity. Charles Darwin, having categorized the behaviors of countless species, famously declared blushing to be the most peculiar and the most human of all expressions. No other animal displays this reaction. While a dog might appear guilty, lowering its head after breaking a rule, it does not turn red. Blushing requires a complex cognitive architecture known as the theory of mind, the innate understanding that other people possess thoughts, judgments, and perspectives separate from your own. You cannot blush unless you care about what another mind is thinking about you. Physiologically, the mechanism of a blush is somewhat of a paradox. It is driven by the sympathetic nervous system, the same engine behind the fight or flight response. Typically, when this system detects a threat, it forces blood away from the skin and toward the skeletal muscles to prepare you to run or fight, causing you to go pale. However, in the specific context of social scrutiny, the body does something unique. Adrenaline triggers beta-adrenergic receptors in the facial veins, causing the tiny muscles lining these vessels to relax instantly. This allows blood to rush into the capillaries just beneath the surface of the skin, transforming the face into a visible beacon of your internal emotional state. From a survival perspective, this might seem like a flaw. Why would evolution favor a trait that broadcasts vulnerability and awkwardness to potential rivals? The answer lies in social cohesion. Blushing functions as an involuntary, nonverbal apology. Because it is physically impossible to blush on command, it serves as an honest signal of contrition. It tells the group that you recognize you have breached a social norm and that you value their opinion enough to be affected by it. Studies have shown that individuals who blush after making a mistake are viewed as more trustworthy and are forgiven more quickly than those who do not. It acts as a rapid de-escalation tool, signaling that you are not a threat to the social hierarchy. It turns the skin itself into a communicative interface, prioritizing social repair over self-defense. Yet color change is only one method the body uses to signal intent. Beneath the surface, an elaborate machinery of muscle fibers works tirelessly to shape the rest of our interactions. Of all the configurations these fibers can create, none is more socially potent or more structurally complex than the smile. We intuitively distinguish between a polite social signal and genuine joy, a distinction first mapped out in the 19th century by the French neurologist Guillaume Duchenne. He determined that while we can voluntarily contract the zygomatic major muscle to pull up the corners of our mouth on command, true happiness engages the orbicularis oculi, the circular muscle surrounding the eye. This involuntary contraction crinkles the outer corners of the eyes, creating what scientists now call the Duchenne smile, a signal of authenticity that is notoriously difficult to fake because the neural pathways controlling voluntary movement are distinct from those handling emotional spontaneity. But the face does more than simply broadcast our internal state to the world. It may actually help generate it. This concept creates a strange physiological loop known as the facial feedback hypothesis. The theory suggests that the physical act of smiling sends sensory data back to the brain, reinforcing or even initiating the feeling of happiness. In classic psychological experiments, participants who held a pen between their teeth, mechanically forcing their face into a smile-like shape without realizing it, rated cartoons as significantly funnier than those who held the pen with their lips, which inhibited the smile muscles. While the magnitude of this effect is a subject of ongoing debate, the core premise suggests that your brain looks to your body to decide how you feel, interpreting the tension of your facial muscles as evidence of your mood. This mechanism extends outward to how we process the feelings of those around us. When you look at a friend in distress or joy, your own facial muscles engage in rapid, often imperceptible mimicry. You subconsciously copy their expression to try it on, sending that same sensory feedback to your own brain to better understand their emotional state. This process is so integral to empathy that studies involving people with facial paralysis, or even those using cosmetic freezing agents like Botox, suggest that when we cannot physically mimic an expression, we become slightly slower and less accurate at recognizing strong emotions in others, as if our own face is the dictionary we use to translate the world. This shared biological language transcends culture and geography. While gestures like a thumbs up, a nod, or a wave can mean drastically different things depending on where you are on the map, the smile is universally understood. It appears to be hardwired into our genetic code rather than learned through observation. We know this because babies born completely blind will still smile in response to a parent's voice or a gentle touch, engaging the exact same complex muscle groupings as a sighted infant. This proves that the instinct to smile is not something we see and copy, but something we are born knowing how to do, a pre-installed software for connection that predates our ability to speak or even see. That pre-installed software does not stop at the boundaries of your own skin. It acts as a transmission signal, bridging the gap between one nervous system and another through a phenomenon psychologists call emotional contagion. This is the mechanism by which moods ripple through a room much like a biological virus, jumping from host to host, often without a single word being spoken. When you are in the presence of someone who is genuinely relaxed, your own respiration and heart rate will often slow down to match theirs, a process known as physiological linkage. Conversely, if a person enters a quiet space carrying suppressed anger or high anxiety, the people around them can detect it almost instantly. This detection happens through micro-expressions, fleeting facial movements that last less than a fifth of a second, which your brain processes subconsciously. You might not consciously realize you saw a flash of annoyance on a colleague's face, yet your amygdala responds by putting your body on a low-level alert. I wonder if you have ever noticed how quickly your own energy shifts simply by sitting next to someone who is visibly calm. This transfer of feeling is so potent that it extends to the chemistry of your blood. Researchers have documented the existence of secondhand stress, revealing that simply observing a stressed individual can cause your own body to release cortisol. This effect is significantly stronger if you have a close relationship with the stressed person, but it happens even with total strangers, proving that empathy is physically taxing. We are designed to be resonant boards for one another, vibrating at the frequencies of those we are near. This resonance is carried not just by sight, but by the subtle acoustics of the human voice. Evolution has tuned the ear to be hypersensitive to emotional prosody, the rhythm, timbre, and pitch of speech. A voice that is low, slow, and resonant tends to down-regulate the nervous systems of listeners, signaling safety, while high-pitched, erratic tempos trigger an immediate sympathetic response. In rare cases, this interconnectivity becomes so intense it creates a feedback loop known as mass psychogenic illness or epidemic hysteria. This occurs when physical symptoms such as dizziness or fainting spread through a group of people solely because they see others suffering from them. There's no toxin or virus present. The pathogen is the shared belief in danger, causing the body to manifest real physical reactions to a phantom threat. It creates a powerful testament to the fact that our minds are not isolated islands, but are continuously permeable to the social weather around us. We are constantly broadcasting and receiving, regulating each other's internal states through invisible waves of sight and sound. However, as influential as these remote signals are, they are effectively overshadowed by the most direct and primal form of social communication available to us. It is a sense that develops before vision and before hearing, serving as the foundational language of trust. This language is spoken through the largest organ you possess, your skin, which acts as a highly sophisticated social receiver. While we typically think of touch as a mechanical tool used to grasp objects or sense temperature, biologically, your skin is engineered for emotional connection. Buried within the hairy skin of your arms and back is a distinct network of nerve fibers known as C-tactile efferents. Unlike the fast-firing nerves that tell you if a surface is rough or smooth, these specific fibers move slowly, prioritizing emotional data over raw physical information. They are tuned to respond to a very specific stimulus, a gentle caress moving at a speed of roughly 3 to 5 centimeters per second. This is not a random preference, but a biological lock and key. When someone strokes your arm at exactly this velocity, it mimics the grooming behaviors of our primate ancestors, signaling safety and belonging. The brain processes this specific type of touch not in the somatosensory cortex where it maps physical sensations, but in the insular cortex, the deep region responsible for emotional processing and self-awareness. This means that a comforting hand on the shoulder is interpreted by your mind less as a physical pressure and more as a distinct emotional event. This mechanism is so powerful that even fleeting, casual contact can alter human behavior in measurable ways. In psychological studies, waitresses who briefly touched a customer on the arm or shoulder while delivering the bill received significantly larger tips than those who did not, regardless of the quality of service. Similarly, library patrons who were accidentally touched by a librarian while checking out a book reported significantly higher satisfaction with the library and their life in general, even if they didn't consciously recall the touch happening. The physical contact acts as a somatic shortcut to trust. When two people shake hands before a negotiation, the skin-to-skin contact suppresses the brain's amygdala, the fear center, and stimulates the release of oxytocin, which promotes cooperation. This is why deals made in person are statistically less likely to fall through than those made over email. The physical seal of a handshake literally changes the neural landscape of the participants, making them less defensive and more open to collaboration. Conversely, the absence of this sensory input creates a distinct physiological deficit known as skin hunger or touch starvation. When the brain is deprived of social touch for extended periods, it perceives a threat to survival, causing a baseline rise in cortisol, the stress hormone. This elevates heart rate and suppresses the immune system, effectively keeping the body in a state of low-grade fight or flight. The necessity of this contact is perhaps most visible in the very beginning of life. For decades, medicine focused on keeping premature infants in sterile incubators to protect them from infection, but they often failed to thrive. It was eventually discovered that infants who received regular, gentle massages gained weight nearly 50% faster than those who did not, despite consuming the same number of calories. The stimulation of the skin activates the vagus nerve, which stimulates the digestive tract and allows the body to absorb nutrients more efficiently. Touch, in this sense, is not merely a luxury or a comfort. For a developing human, it is a biological requirement as vital as food, signaling to the fragile nervous system that it is safe enough to grow. This sense of safety is orchestrated by a molecule that has captured the popular imagination like no other, often referred to as the love hormone or the cuddle chemical. While these nicknames are charming, they vastly simplify a much more sophisticated biological reality. For oxytocin is not merely a potion for affection, it is a complex neuromodulator of social relevance. When this peptide is released in the brain, it targets the amygdala, the almond-shaped cluster of neurons responsible for processing fear and threat detection. By dampening the amygdala's activity, oxytocin literally quiets the noise of anxiety, lowering the psychological barriers that usually keep us guarded. It acts as a chemical permission slip, allowing the brain to interpret proximity as safety rather than danger, effectively inhibiting the instinct to flee. However, this chemical does not indiscriminately flood the world with benevolence. Research reveals a fascinating paradox known as the oxytocin conceptualization of social defense. While it enhances trust and empathy towards those we perceive as part of our in-group, our family, our team, or our community, it can actually sharpen our suspicion towards out-groups. In high-stress scenarios, elevated oxytocin has been linked to increased defensive aggression against those perceived as outsiders or threats. It turns out that the chemistry of connection is also, by necessity, the chemistry of exclusion. To fiercely protect us, the brain must clearly define them, creating a biological basis for loyalty that can, under the wrong circumstances, morph into tribalism. This fierce protection has its roots in the most primal of mammalian experiences, for long before it governed social politics, oxytocin was the engine of birth itself. The very word comes from the Greek for swift birth, as it is the driving force behind uterine contractions during labor and the biological signal for milk letdown during breastfeeding. In those early moments of life, a massive surge of this hormone creates a unique window of plasticity in the maternal brain, rewiring neural pathways to prioritize the infant above all else. It ensures that the fatigue of parenthood is overridden by a chemical mandate to bond, establishing a feedback loop where physical touch triggers the release of more oxytocin, which in turn encourages more touch. Scientists have observed this distinct bonding effect in laboratory settings using economic trust games, where participants who received a nasal spray of oxytocin were significantly more likely to entrust their money to a stranger than those who received a placebo. They did not become gullible to obvious risks, but they became biologically willing to overcome the natural hesitation of social uncertainty, displaying a reduced fear of betrayal. It suggests that our capacity to build civilizations, trade networks, and cooperative societies relies heavily on this ancient peptide's ability to suspend our disbelief in one another. Yet this chemical bridge between minds is not built in silence, as the internal chemistry of connection inevitably seeks an external outlet, often manifesting through the most primitive instrument we possess, the voice. This vocal instrument is surprisingly malleable, shifting its shape and frequency without our conscious permission the moment we enter the presence of others. Research into the acoustics of social interaction reveals that when we speak to someone we feel an affinity for, our pitch naturally rises, a phenomenon scientists call vocal accommodation. This subtle shift toward a higher frequency is not merely a habit, but a biological signal of non-aggression, a way of making our presence feel smaller and safer to the person we wish to connect with. Conversely, when we seek to establish dominance or authority, the larynx relaxes, deepening the voice to occupy more sonic space, a trait that persists even in modern corporate boardrooms. We also instinctively engage in convergence, a process where we subconsciously mimic the tempo, volume, and rhythm of our conversation partner's speech. If they speak quickly, we speed up. If they whisper, we lower our volume, creating a synchronous rhythm that acts as a sonic handshake, signaling that we are part of the same tribe. Have you ever caught yourself slipping into a higher, polite customer service voice when answering a call, only to drop back to your normal register the moment you hang up? This instinct to alter our tone reaches its peak in the universal phenomenon of infant-directed speech, colloquially known as baby talk or motherese. While often dismissed as silly, this high-pitched sing-song cadence is actually a sophisticated teaching tool that appears in nearly every culture and language on Earth. The exaggerated vowels and slow tempo help the infant brain map the sounds of language. But more importantly, the melodic contours carry distinct emotional data that a pre-verbal brain can understand perfectly. Remarkably, this social instinct is so deeply hardwired that even parents who use sign language will unconsciously slow down their hand movements and use larger, more exaggerated gestures when signing to babies, creating a visual form of motherese. This brain processes these melodic aspects of speech, known as prosody, in a completely different region than it processes the actual definitions of words. While the left hemisphere typically handles the semantics and syntax, the what of the sentence, the right hemisphere is busy decoding the how, analyzing the rise and fall of the pitch to interpret sarcasm, affection, or anger. This is why you can often understand the emotional state of a conversation happening in another room, even if the walls are too thick to make out the specific words. This separation of tone and text is so distinct that there are rare neurological conditions where a person can understand the definition of every word spoken to them, but becomes completely deaf to the emotion behind it, hearing a weeping confession as a flat, robotic statement of fact. However, the most powerful sound the social brain can process is one specific acoustic pattern: your own name. The cocktail party effect describes the brain's ability to filter out a chaotic room of chatter to focus on one voice, but hearing your name triggers a unique override. It activates the medial prefrontal cortex, a self-referential part of the brain, instantly pulling your attention away from everything else. This neural tag is so potent that it is one of the few sounds that can penetrate deep sleep, alerting the resting mind that the social world requires its presence. Once that attention is secured, the content of the conversation takes over, and curiously, the most captivating subject tends to be other people. While modern society often dismisses gossip as a trivial or even malicious habit, evolutionary psychologists view it through a much more pragmatic lens. In the grand scheme of survival, gossip is not a vice, it is the sophisticated glue that holds large societies together, functioning as a form of distant social grooming. To understand this, consider how our primate cousins maintain their alliances. Chimpanzees and bonobos build trust through physical touch, spending hours picking through one another's fur to remove ticks and dirt. This grooming process releases a cascade of endorphins and oxytocin, forging deep bonds between individuals. However, physical grooming has a strict limitation. It is incredibly time-consuming, and you can only groom one ally at a time. As early human groups began to expand in size, there simply weren't enough hours in the day to physically touch every member of the tribe to ensure loyalty. Language evolved in part to solve this logistical problem. It allowed our ancestors to engage in vocal grooming. By sitting around a hearth and sharing stories about the day, humans could effectively groom several people simultaneously. You can talk to 3 or 4 peers at once, maintaining those crucial bonds, all while your hands remain free to weave baskets, carve tools, or prepare food. This efficiency allowed human social circles to expand far beyond the limits seen in other primates, creating networks of up to 150 individuals who felt connected through shared words rather than shared touch. This exchange of information served a second, equally vital survival function. It acted as a policing mechanism. In a cooperative hunter-gatherer society, the greatest threat to survival was the free rider, the individual who consumed shared resources but refused to contribute to the collective effort. Gossip became the tribe's distributed database of reputation. By sharing information about who was generous and who was selfish, the group could identify untrustworthy members without requiring a centralized authority. The fear of being the subject of negative gossip acted as a powerful psychological deterrent, enforcing cooperation. If you knew your reputation would travel faster than you could, you were far more likely to share your food and adhere to the group's norms. This ancient drive to monitor the social network remains the dominant force in our daily interactions. Research into human conversation reveals that, regardless of culture, age, or profession, approximately 65% of all speaking time is dedicated to social topics, discussing who likes whom, who is fighting, and the shifting dynamics of our peers. We are biologically obsessed with these details because for millions of years, being excluded from the social loop was a death sentence. Yet, simply knowing what others are doing is not enough. To truly leverage this social data, the brain must take a leap from observation to simulation, attempting to guess the invisible thoughts driving those actions. This capability is formally known as theory of mind, a somewhat misleading term that refers not to a scientific hypothesis, but to the intuitive theory we all construct about the internal lives of others. It is the profound recognition that the people around you are not merely moving objects or automated scripts, but distinct conscious entities with their own private beliefs, desires, and intentions, all of which may differ radically from your own. While this might seem like a basic assumption of daily life, it is actually a complex cognitive achievement that the human brain does not possess at birth. We must grow into it, shedding the infant's assumption that the world is exactly as we see it and that everyone else sees it the same way. The development of this skill is beautifully illustrated by a famous psychological experiment known as the Sally-Ann test, which reveals the precise moment a child learns to step outside their own perspective. In this scenario, a child is introduced to 2 characters, Sally and Ann. The narrative is simple and deceptive. Sally has a basket, and Ann has a box. The child watches as Sally places a marble into her basket and then leaves the room to go for a walk. While Sally is away, the mischievous Ann takes the marble out of her basket and hides it in her own box. When Sally returns to the room, the child is asked a critical question. Where will Sally look for her marble? To an adult, the answer is obvious. Sally will look in the basket because that is where she left it. She has a false belief about the marble's location. However, children under the age of 4 almost invariably fail this test. They point to the box, unable to distinguish between what they know to be true, the marble is in the box, and what Sally knows to be true based on her limited experience. They cannot yet hold 2 conflicting representations of reality in their minds simultaneously. It is usually around the age of 4 or 5 that the brain undergoes a significant update, allowing the child to realize that Sally's mind contains a perspective different from the reality of the room, marking the official arrival of a functioning theory of mind. Once this software is installed, it runs in the background of almost every social interaction you will ever have, allowing you to simulate the minds of others with startling speed. You do not merely observe behavior, you predict it by running a mental simulation of what it is like to be someone else. When you see a friend glance at their watch, you do not just see a movement of the wrist, you infer impatience or perhaps anxiety about a meeting. You are constantly running what-if scenarios, calculating how a specific comment might make a partner feel, or how a colleague might interpret your silence. This is the brain decoupling from the immediate physical environment to wander through the invisible landscape of another person's thoughts. When this mechanism falters, however, the social world transforms into a bewildering place. From individuals who struggle with theory of mind, often observed in various neurodivergent conditions, the actions of others can appear abrupt and inexplicable. Without the ability to intuitively infer the hidden agenda or the false belief driving a person's actions, social navigation becomes like trying to drive through a busy city without understanding traffic signals. One is left to memorize rote patterns of behavior without grasping the underlying intent, highlighting that our ability to connect is not just about shared space, but about the shared imagination of each other's inner worlds. This imaginative leap happens with frightening speed, suggesting that we do not wait to gather evidence before forming a complete impression of a stranger. Your brain creates a working model of a person's character in less time than it takes to blink. Neuroimaging studies reveal that the amygdala makes judgments about a person's trustworthiness and dominance within roughly 100 milliseconds of seeing their face. This is arguably the fastest complex calculation the human brain performs, prioritized by evolution to determine safety before you have even consciously registered who is standing in front of you. This rapid-fire cognition is often called thin slicing, a term used to describe the brain's ability to find accurate patterns in extremely narrow windows of experience. In one famous demonstration of this capability, observers were asked to assess the effectiveness of a teacher they had never met, based solely on a silent video clip lasting fewer than 10 seconds. Astonishingly, their snap judgments matched the detailed end-of-semester evaluations given by students who had spent months in that teacher's classroom. The social mind is a prediction machine, capable of extrapolating a person's entire demeanor from the slightest furrow of a brow or the angle of their posture. However, this efficiency comes with a significant margin for error. Because the brain is desperate to categorize people quickly to save energy, it relies heavily on cognitive shortcuts like the halo effect. This is the pervasive bias where we assume that because someone possesses one positive trait, they must possess others. If a person is physically attractive or confident, the social brain automatically assumes they are also intelligent, kind, and competent, even without a shred of evidence to support that belief. We paint a halo around them, filling in the blanks of their personality with optimistic guesses rather than objective facts. This suggests that our perception of others is often a reflection of our own mental templates as much as it is reality. We are constantly projecting a narrative onto the people we meet, using thin slices of data to build a hologram of who we think they are. It explains why first impressions are notoriously difficult to shake. Once the brain has built its initial model, it prefers to filter out contradictory information rather than rebuild the profile from scratch. Yet, despite the biases, thin slicing remains a critical survival tool. It is the engine behind what we call a gut feeling. It's your subconscious processing micro-expressions, fleeting emotional signals that last only a fraction of a second, faster than your conscious mind can name them. You might feel uneasy around someone smiling at you because your brain detected a micro-expression of contempt that vanished before you could truly see it. This rapid processing highlights that social cognition is not just an intellectual exercise, but a deeply sensory experience where we feel the intent of others before we think about them. setting the stage for how we eventually bond. This connection goes deeper than just seeing. It extends into the physical rhythm of our lives. When you walk alongside a friend, you might notice that your footsteps eventually fall into a perfect cadence with theirs without you ever consciously trying to match their pace. This phenomenon is known as behavioral synchrony, a subtle form of mimicry where our motor systems align with those around us to create a sense of social cohesion. It happens almost everywhere, often beneath our awareness. Research has surprisingly shown that if two people sit in rocking chairs side by side, they will inevitably begin rocking at the same speed, their movements locking into a shared frequency as if connected by an invisible gear. This is not merely imitation, it is a biological imperative to synchronize, signaling to our primal brains that we are safe and that we are part of the same unit. It is a profound feeling, this temporary loss of individual boundaries. Have you ever felt that strange, sweeping sensation of losing yourself in a crowd at a concert or a sports game? I would love to hear about those specific moments where you felt like just one drop in a massive, moving wave of people. That distinct sensation is often described by psychologists as a dissolution of the self. When we move in time with others, whether we are marching in a parade, dancing in a nightclub, or singing in a choir, our brains actually reduce activity in the regions responsible for distinguishing me from you. We effectively become a single organism, a hive mind focused on a shared intent. This is likely why music is a universal feature of every known human society. It provides an external framework, a beat, that allows hundreds of individuals to synchronize their movements instantly. Historians and anthropologists have referred to this as muscular bonding. The act of moving together creates a reservoir of goodwill and trust that persists long after the music stops or the movement ceases. Controlled studies have found that people who engage in synchronized activities, like tapping a rhythm together or walking in step, are significantly more likely to cooperate with each other in subsequent tasks compared to those who moved out of time. They share more resources, trust one another with financial decisions, and sacrifice more for the group. This cooperation is fueled by a powerful chemical cocktail. Synchronized movement triggers a robust release of endorphins, the brain's natural painkillers. These neurochemicals provide a mild euphoria and have been proven to increase our tolerance for physical discomfort. It is the same mechanism behind the runner's high, but shared across a group, bonding them through a collective neurochemical surge. This deep-seated drive to synchronize helps explain why armies march in lockstep and religious congregations chant in unison. It solidifies the group identity and raises the threshold for pain and effort. However, this capacity to merge with the crowd has a complex flip side. The same mechanism that fosters cooperation also opens the door to unthinking compliance. As our brains lock into the group's rhythm, we become more susceptible to the will of the majority, setting the stage for a powerful psychological force known as conformity. This force was most famously dissected in a laboratory at Swarthmore College in 1951, where Solomon Asch devised a test that appeared deceptively simple. He invited students to sit around a table for what they believed was a visual perception task. The setup was straightforward. The group was shown a card with a single vertical line, followed by a second card featuring 3 lines of varying lengths. The participants merely had to identify which of the 3 lines matched the length of the first one. The answer was always obvious, clear as day to anyone with functioning eyesight. However, there was a catch that the subject of the experiment did not know. Everyone else at the table was an actor working for Asch. For the first few rounds, the actors gave the correct answers, establishing a comfortable rhythm. But then, on a prearranged signal, the group began to unanimously choose the wrong line. They would confidently assert that a short line was the long one, or that a long line was the short one. The true participant, sitting at the end of the row, had to watch as person after person gave an answer that blatantly contradicted the evidence of their own senses. As the experiment progressed, the tension in the room became palpable. The participants found themselves caught in a profound psychological dilemma. Their eyes told them one thing, but the social reality told them another. Osh found that the pressure to align with the group was so overwhelming that 75% of participants conformed to the group's incorrect answer at least once. They denied what they saw with their own eyes simply to remain in sync with the strangers around them. When asked later why they had gone along with the group, many admitted they knew the answer was wrong but feared the ridicule or awkwardness of standing alone. Modern neuroscience has since illuminated exactly why this social pressure is so difficult to resist. When researchers replicated Osh's work while monitoring brain activity, they discovered that nonconformity carries a steep neural price. When you realize your opinion deviates from the group consensus, the brain generates a prediction error signal, a distinct flash of neural distress. This activity often centers in the anterior cingulate cortex and the amygdala, areas associated with pain processing and fear. Essentially, the brain processes social disagreement much like it processes a physical mistake or threat. Standing alone against a crowd does not just feel awkward, it triggers a deep-seated evolutionary adaptation. For our ancestors, being out of step with the tribe was a literal survival risk. If the entire group suddenly froze or ran in terror, the individual who paused to debate the logic of the reaction usually did not pass on their genes. We are the descendants of those who followed the herd. Psychologists distinguish between two types of this influence: normative social influence, where we conform to be liked or avoid social punishment, and informational social influence, where we conform because we genuinely believe the group possesses knowledge that we lack. Under the weight of the majority, the brain often decides that it is statistically safer to assume the group is right and your own senses are wrong, prioritizing collective cohesion over individual accuracy. This internal drive to blend in is often amplified by a persistent trick of the mind that convinces us we are constantly being observed. We tend to navigate our social environments with the unshakable sensation that a high-intensity spotlight is trained directly on us, highlighting every small flaw, every awkward silence, and every misplaced word. This phenomenon is appropriately known as the spotlight effect, and it suggests that we drastically overestimate the extent to which others notice our appearance and behavior. The roots of this bias were famously exposed in a clever experiment conducted at Cornell University by psychologist Thomas Gilovich and his colleagues, who wanted to measure exactly how well our social anxiety matches social reality. To do this, they recruited college students and asked them to put on a t-shirt that was specifically chosen to be uncool at the time, featuring a large distinctive image of the singer Barry Manilow. The students, feeling self-conscious and awkward, were then sent into a room filled with other students who were busy filling out questionnaires. After a brief period, the t-shirt wearers left the room and were asked to estimate how many people had noticed their attire. The participants were convinced that their embarrassment was beaming across the room. On average, they predicted that about half of the observers would have definitely noticed the shirt. They felt conspicuous, as if the image on their chest was the only thing anyone could see. However, when the researchers interviewed the people actually sitting in the room, the results were telling. Only about 20% had noticed the shirt at all. The wearers had overestimated the crowd's attention by a massive margin, proving that the spotlight they felt was largely a hallucination of their own making. This gap exists because of an egocentric bias, a natural cognitive limitation where we struggle to step outside our own perspective. You are the center of your own universe, the narrator of your own story, and the only person who has access to your internal monologue. Because you are hyper-aware of your own existence, you assume that your presence is the anchor or the baseline for everyone else's reality. If you have a small coffee stain on your shirt, you know it is there, so it feels massive to you, dominating your awareness. Consequently, you assume it must be equally obvious to everyone else. But the truth is far more comforting. Other people are the protagonists of their own movies, not the audience members of yours. They're consumed by their own thoughts, their own insecurities, and their own to-do lists. Their eyes may sweep past you, but their minds are rarely recording the details you were agonizing over. The spotlight effect teaches us that the world is not watching us with a magnifying glass. In fact, most of the time, we're enjoying a blissful sort of invisibility, free to be imperfect without the audience we imagine. However, this internal sense of freedom changes instantly when the perceived audience shifts from a peer to a superior. Our social brains are wired for hierarchy, a survival mechanism that dates back to our earliest ancestors who needed clear chains of command to organize hunts or defend the tribe. This deep coding is what Stanley Milgram famously probed in his psychology experiments during the 1960s. While the specifics of his work are often discussed in terms of ethical controversy, the quieter, more profound finding was the discovery of what he called the agentic state. Milgram proposed that humans have evolved the ability to make a fundamental shift in consciousness when confronted with a legitimate authority figure. In this state, an individual stops viewing themselves as an autonomous person responsible for their own actions and instead views themselves as an agent executing the wishes of another. It is a psychological surrender that acts as a potent sedative for the conscience. The heavy burden of decision-making and the anxiety of personal responsibility are lifted, placed squarely on the shoulders of the authority figure. This is why obedience can feel almost hypnotic to the human mind. It simplifies the world. The brain quiets its critical faculties to maintain social cohesion. Recent neuroimaging studies have supported this theory, showing that when people follow orders, they report feeling a greater sense of distance between their actions and the outcomes, processing the event almost as if they were a passive machine rather than an active participant. This effect is so potent that it does not require a dictator or a general to activate it. Simple symbols are often enough to hijack the brain's executive function. Clothing, remarkably, is one of the strongest triggers for this neural switch. The brain is an efficient organ that relies on visual shortcuts to assess status, and it responds automatically to uniforms. In field experiments where a Confederate jaywalks against a red light, pedestrians are significantly more likely to follow them into dangerous traffic if the jaywalker is wearing a high-status business suit versus casual denim. The suit acts as a safety signal, tricking the observer's brain into assuming the rule breaker has special knowledge, status, or permission that validates the risk. We see this in hospitals as well, where the white coat effect commands an automatic, unthinking deference. We are programmed to look for these badges of rank, because for the brain, following a leader is energy efficient. It saves us the metabolic cost of analyzing every single situation from scratch, allowing us to outsource our judgment to someone who appears to know better. Yet this reliance on external cues extends beyond direct orders from above, bleeding into how we navigate the world alongside our equals, shifting us from active followers of authority to passive mimics of the crowd. This mimicry becomes dangerous when the crowd itself is paralyzed, creating the psychological trap known as the bystander effect. We intuitively believe there's safety in numbers, assuming that if we were to collapse on a busy sidewalk, the sheer volume of witnesses would guarantee immediate aid. However, the architecture of the social brain often dictates the opposite result. The more people present during an emergency, the less likely any single individual is to offer help. This is not necessarily born of cruelty or apathy, but of a mathematical dilution of duty known as the diffusion of responsibility. When you're the only witness to a crisis, the pressure to act is concentrated entirely on you. The burden is 100% yours, and the cost of inaction is a direct blow to your self-image. But in a crowd of 50, that burden is mentally divided, leaving you with only a fraction of the obligation. The brain rationalizes that surely someone else, someone closer, someone with medical training, or perhaps just someone more confident, is already handling it.
This leads to a collective hesitation where everyone waits for a savior who never steps forward. This hesitation is compounded by a cognitive feedback loop called pluralistic ignorance. In ambiguous situations, our brains frantically scan the faces of those around us to gauge the appropriate emotional response. If we see smoke drifting from under a door, we might feel a spike of fear, but before we scream fire, we look at our neighbors. If they appear calm, we suppress our panic to avoid the embarrassment of overreacting. The tragedy is that everyone else is doing the exact same thing. They are masking their anxiety to blend in, creating a room full of people who are internally terrified but outwardly stoic. The group unknowingly conspires to convince itself that everything is fine, maintaining a veneer of calm even as danger mounts. In famous psychological experiments, subjects placed in a room filling with smoke would sit passively for minutes, coughing and waving away fumes, simply because the Confederates around them refused to react. The social instinct to conform is so potent that it can override the biological instinct for survival. Breaking this spell requires piercing the anonymity of the crowd. This is why emergency response training emphasizes that you must never shout a general plea for help to a group. To activate the social brain's helpfulness, you must convert the crowd back into individuals. By pointing at a specific person and giving a direct command, "You in the red shirt, call 911, you instantly dissolve the diffusion of responsibility. That specific person can no longer assume someone else will act. The burden has been returned to them in full, snapping them out of the collective trance and re-engaging their personal sense of agency. Once that individual agency is engaged, however, the brain immediately seeks context, performing one of its most ancient and rapid calculations, determining who belongs to your tribe and who does not. This process of sorting the world into us and them is not a learned habit that takes years to develop. It is a fundamental operating system of the social mind that activates faster than you can blink. Neuroimaging studies show that the amygdala, the brain's alarm bell, can differentiate between an in-group face and an out-group face in as little as 170 milliseconds. Before you have even consciously registered the person standing in front of you, your brain has already decided whether they are a potential ally or a stranger, tagging them with a subtle emotional valence that colors every interaction that follows. What is truly startling is how little it takes to trigger this tribal loyalty. While we often assume that deep divisions are caused by centuries of history, religion, or politics, psychologists have demonstrated that the brain will manufacture loyalty over the most trivial differences imaginable. This phenomenon is known as the minimal group paradigm. In the 1970s, the social psychologist Henry Todgefell showed that if you divide complete strangers into groups based on something entirely arbitrary, like whether they overestimated or underestimated the number of dots on a screen, or whether they preferred a painting by Klee over a painting by Kandinsky, they will immediately begin to discriminate. Within minutes, people will award more money and resources to the members of their meaningless dot-estimating group and withhold resources from the others. It reveals that the specific content of the group doesn't matter. The brain simply craves a category. It wants to know who we are, so it knows who they are. This categorization has profound physical effects on how we experience empathy. When you watch a member of your own group experience pain, whether it is a needle pricking their hand or a stumble on the sidewalk, your brain's pain matrix lights up in sympathy. You quite literally run a simulation of their suffering in your own neural circuitry. But when you watch a member of an out-group experience that same pain, this sympathetic response is significantly dampened. The brain quiets the signal, creating a neurological gap in empathy that allows us to disconnect from the suffering of those we label as other. Fortunately, this system is as flexible as it is fast. The definition of us is not fixed in stone. It is fluid and constantly being rewritten by the context of the moment. In a famous study involving British football fans, researchers found that Manchester United fans were far less likely to help an injured runner if he was wearing a rival Liverpool shirt. However, when the researchers reminded the fans of their shared identity as fellow football lovers before the incident, the boundaries expanded. Suddenly, the rival shirt didn't matter. The injured runner was recategorized from enemy to fellow fan, and the empathy circuit roared back to life. The neurology of exclusion is powerful, but it is ultimately a trick of perspective, one that we have the power to shift simply by widening the circle of who we consider to be part of our team. Once we have established who is on our team, the brain immediately pivots to a more precarious question: where do we stand within it? It is an uncomfortable truth that the human brain is profoundly obsessed with hierarchy, constantly monitoring your relative standing compared to those around you in a process that occurs largely beneath your conscious awareness. This sensitivity to rank is not merely a matter of vanity or ego, but a deep evolutionary adaptation designed to minimize conflict. If every member of a group instinctively understands their place, energy-expensive physical fights become unnecessary. The machinery of this status tracking is largely chemical. When your brain perceives that your social standing has risen, perhaps you won an argument, received a promotion, or were complimented by a stranger, it releases serotonin. This neurotransmitter does more than simply improve your mood. It acts as a regulator of confidence. Higher serotonin levels physically alter your posture, making you stand taller, and they reduce your sensitivity to negative feedback, encouraging you to take social risks. You become calmer and more fluid in your movements. Conversely, when status drops, serotonin levels deplete, leading to a state of hypervigilance where the world feels more dangerous and the mind begins to obsess over potential threats. The consequences of this system extend far beyond temporary feelings of confidence. In landmark studies of baboon troops on the African savanna, researchers discovered that individuals at the bottom of the hierarchy lived with chronically elevated cortisol levels. They were effectively experiencing the physiological stress of being chased by a predator, but sustained 24 hours a day. This constant chemical bath damaged their immune systems and even shrank the memory centers of their brains. The findings are remarkably similar in humans. The famous Whitehall studies, which tracked thousands of British civil servants over decades, revealed a distinct social gradient in health. Even when controlling for lifestyle factors like smoking or diet, those in lower employment grades suffered significantly higher rates of heart disease and mortality than those at the top. It appears that the subjective feeling of having low status, of having less autonomy and control than your peers, triggers a sustained inflammatory response that wears down the body over time. However, the human social mind has evolved a critical workaround that separates us from our primate cousins. In most of the animal kingdom, status is almost exclusively about dominance. Ranking is determined by who is the strongest, the loudest, or the most aggressive. While humans certainly still engage in dominance hierarchies, we have developed a second, more sophisticated path to high status, known as prestige. While dominance relies on fear and intimidation, prestige is granted freely by the group based on respect, skill, and knowledge. A leader who holds status through prestige, by being the most helpful, wise, or skilled, actually lowers the stress levels of the group. We are wired to seek proximity to prestigious individuals, not to submit to them, but to learn from them. Your brain is sophisticated enough to distinguish between a bully and a mentor, and while it may comply with the bully out of self-preservation, it reserves its deepest loyalty and biological synchronization for those who have earned their rank through competence. This biological loyalty extends beyond the vertical structures of rank and hierarchy, settling deep into the horizontal bonds of friendship. While we often think of friends as people we simply enjoy passing time with, neuroscience reveals that friendship is a fundamental mechanism for energy conservation and survival. When researchers at Dartmouth College mapped the social networks of an entire class of students and then placed them in fMRI scanners, they discovered something remarkable about the nature of these connections. By watching how their brains reacted to a variety of video clips, the scientists could predict which participants were close friends solely based on their neural activity. The scans showed that friends share a distinct neural signature, responding to the world with synchronized patterns of attention and emotional processing. This neural homophilia suggests that your brain actively scans the environment for minds that operate like your own, creating a shared reality that reduces the cognitive effort required to communicate and predict behavior. In the ancient environment where your brain evolved, this synchronization was a matter of life and death. One of the primary evolutionary drivers for these tight-knit, non-familial bonds is the concept of alloparenting, or allomothering. This term describes a system where care for offspring is shared among the group rather than falling solely on biological parents. By forming deep, trustworthy alliances, early humans could distribute the immense caloric and attentional cost of raising vulnerable children. Your brain is wired to view a close friend not just as a companion, but as a co-regulator of your survival needs, someone who can take over the watch when you need to sleep or hunt. This deep reliance is why the mere presence of a friend can physically alter your perception of reality. In a fascinating perception study, participants were asked to estimate the steepness of a hill while standing at its base. Those standing alone consistently perceived the hill as steep and daunting. However, those standing next to a friend saw the same hill as significantly shallower and easier to climb. The visual cortex, communicating with the brain's resource management centers, actually adjusted the visual input based on the available social support.
The hill looked less difficult because, biologically speaking, it was less difficult. The brain calculated that the journey's metabolic cost could be shared or supported by the companion. This leads to what neuroscientists call social baseline theory. For decades, psychology assumed that being an individual was the baseline state and adding people was a variable. The new understanding flips this entirely. The human brain expects to be embedded in a social network as its default setting. Being alone is recognized by the brain as a state of high alert and effort, triggering a constant low-level release of stress hormones to prepare for independent survival. Friendship is the signal that allows the brain to stand down, conserving metabolic resources and quieting the alarm systems. Yet, as profound as this soothing effect is, there is another biological force that takes this connection and amplifies it into something far more volatile. We must now turn our attention to the intense, obsessive, and chemically overwhelming neural machinery of romantic love. When a person falls deeply in love, the brain does not simply release a gentle wave of warmth. It activates a potent biological drive that is distinct from sexual arousal or simple affection. Neuroscientists scanning the brains of the newly love-struck have found immense activity in the ventral tegmental area, a primitive part of the brain responsible for producing dopamine. This region is a central component of the brain's reward system, the same neural network that is stimulated by addictive substances like cocaine or nicotine. This explains why the early stages of romance feel less like a choice and more like a thirst that must be quenched, characterized by intense focus, high energy, and a craving that can border on painful when the beloved is absent. This biological state is so consuming that serotonin levels in the brains of new lovers often drop to match those found in patients with obsessive-compulsive disorder. This depletion is what drives the intrusive circular thoughts that make it nearly impossible to focus on work or daily tasks, as the brain forces your attention back to the object of your affection. But the brain does not stop at merely amplifying desire. It also actively suppresses the machinery of caution. As the dopamine-rich reward centers light up, the frontal cortex, the seat of judgment, criticism, and logic, shows a marked decrease in activity. Neural scans reveal a distinct deactivation in the areas responsible for social assessment and negative emotions, providing the biological basis for the old saying that love is blind. Your brain effectively suspends its ability to see flaws or assess risk, creating a protected bubble where the bond can solidify without the interference of critical analysis. Even the amygdala, which typically sounds the alarm for fear, quiets down, allowing for a reckless sort of vulnerability that would otherwise feel unsafe. However, this high-octane state of passionate arousal is metabolically expensive and unsustainable for the human body to maintain indefinitely. Over time, usually within 1 to 2 years, the brain naturally shifts gears from the thrill of acquisition to the calmer, deeper waters of attachment. This phase is governed less by the frantic energy of craving and more by the stabilizing influence of oxytocin and vasopressin, the chemicals of contentment and security. Speaking of that sense of security, I'm curious to know what specifically triggers that feeling of safety for you. Is there a particular sound, like rain on the roof, or perhaps a specific voice or memory that instantly calms your mind? Feel free to share that comforting thought in the comments. This transition to long-term attachment is deeply rooted in our biology, a mechanism we share with a surprising creature, the prairie vole. These small rodents are famous in neuroscience because they form lifelong monogamous pairs, unlike their close genetic cousins, the montane voles, which remain promiscuous and solitary. The difference lies not in their will or social structure, but in the density and location of receptors for oxytocin and vasopressin in their brains. When scientists blocked these receptors in prairie voles, the animals lost interest in their partners, proving that devotion is, at a chemical level, a specific lock and key mechanism. For humans, vasopressin plays a particularly interesting role, often linked to behaviors of protection and mate guarding. We are wired to transition from the spark of obsession to the warm glow of companionship, ensuring that we remain connected long after the initial chemical storm has passed. However, when these profound connections are severed, the biological machinery that once provided security turns against us, treating the absence of a loved one not just as a sentimental loss, but as a threat to survival. The brain does not simply return to its solitary baseline. Instead, it plunges into a state of physiological turmoil that mirrors the withdrawal symptoms of a drug addict. Because the neural pathways for social bonding rely heavily on the brain's reward system, utilizing dopamine and endogenous opioids, the sudden removal of a partner creates a chemical deficit. Neuroscientists have observed that the cravings a grieving person feels for a lost partner light up the exact same regions of the brain as a person detoxing from cocaine or heroin, proving that love is, biologically speaking, a habit that is physically painful to break. This overlap between emotional and physical distress is not merely a metaphor. Functional MRI scans reveal that social rejection activates the anterior cingulate cortex and the anterior insula, the specific regions responsible for processing physical pain. The brain essentially recycles the neural circuitry evolved to alert you to a broken bone or a burn, using it to alert you to a broken social bond. This conservation of energy explains why emotional anguish is often felt as a somatic ache in the chest or stomach. In fact, this link is so literal that studies have shown over-the-counter painkillers, such as acetaminophen, can marginally reduce the intensity of hurt feelings, suggesting our neurons struggle to distinguish between a bruised arm and a bruised ego. In extreme cases, the body's reaction to social shock can be life-threatening. There is a documented medical condition known as Takotsubo cardiomyopathy, or broken heart syndrome, where a sudden surge of stress hormones, particularly adrenaline and norepinephrine, temporarily stuns the heart muscle. This chemical flub causes the left ventricle to balloon outward, inhibiting its ability to pump effectively.
The name comes from the Japanese word for octopus trap because the misshapen heart resembles the ceramic pots fishermen once used to catch octopuses. While it mimics the symptoms of a heart attack, there are usually no blocked arteries, and the heart typically recovers. Yet it serves as a stark reminder of how deeply our social lives are entangled with our cardiovascular health. Beyond the immediate shock, the brain faces a longer, more arduous task, updating its map of reality. The brain is fundamentally a prediction machine, constantly forecasting what will happen next to save energy. When you share a life with someone, your brain encodes them as a permanent fixture of your environment, integrating them into your very sense of self. You subconsciously outsource cognitive tasks to them, a phenomenon called transactive memory, where they remember the dates and you remember the directions. When they are gone, your hippocampus continues to predict their presence, resulting in a jarring prediction error every time you reach for a phone to text them or turn to speak to an empty chair. Grief, from a neurological perspective, is the painful, slow process of rewriting neural architecture to reflect a world where that person no longer exists. This resistance to updating is why grief comes in waves. It is the brain failing a prediction, realizing the error, and being forced to recalculate its model of the world over and over again. Eventually, the acute pain of loss subsides, but for some, the absence of connection becomes a permanent state, leading us to the chronic condition of lacking connection entirely. This state is what researchers define as loneliness, though it is vital to distinguish this experience from the simple physical fact of being alone. Solitude can be a sanctuary, a restorative quiet where the mind consolidates its thoughts and finds peace. Loneliness, by contrast, is not measured by the number of people in a room, but by the subjective gap between the connection you desire and the connection you actually perceive. You can feel entirely whole while sitting alone in a forest, yet feel devastatingly isolated in a bustling city center or at a crowded party. It is a distress signal as biological and urgent as hunger or thirst. Just as hunger tells you that your body needs energy to survive, loneliness is a neural alert system screaming that your social body needs the tribe to remain safe. However, when this signal remains active for too long, it ceases to be a helpful alert and becomes a source of profound physical wear and tear. Medical researchers have found that the long-term health impact of chronic loneliness is staggering, with mortality risks comparable to smoking 15 cigarettes a day, exceeding the dangers of obesity or a sedentary lifestyle. This happens because the human body, when it feels socially isolated, assumes it is in immediate physical danger. Without the protection of the group, our ancient programming assumes we are vulnerable to predators, so the brain triggers a low-level, constant fight-or-flight response. This floods the system with cortisol, increases vascular resistance, and even alters the expression of genes related to the immune system, increasing systemic inflammation while simultaneously lowering the body's antiviral defenses. Sleep becomes fragmented as the lonely brain refuses to fully power down, keeping the sleeper in a state of micro-arousal to listen for approaching danger. The mind, trapped in this state of perceived peril, undergoes a radical shift in how it processes reality. It enters a mode known as social hypervigilance. While the conscious mind may be yearning for warmth, trust, and conversation, the subconscious brain is busy scanning the horizon for threats. It becomes essentially paranoid, looking for signs of rejection or hostility with high-speed precision. In laboratory settings, lonely individuals detect negative social cues in a fraction of a second, much faster than socially connected people do. However, this speed creates errors. The hypervigilant brain begins to hallucinate malice where there is none, interpreting a neutral face as angry, a delayed text message as a calculated rejection, or a casual comment as a personal insult. This creates a heartbreaking, self-sustaining cycle.
Because the world feels unsafe and others appear hostile through this distorted lens, the lonely individual unknowingly puts up walls.
They may become prickly, withdrawn, or cynical to protect themselves from the anticipated pain of further exclusion. This behavior, driven by the brain's misguided attempt at self-preservation, inevitably pushes others away, confirming the brain's fear that it is indeed alone. It is a biological paradox where the remedy, reaching out and being vulnerable, feels like the most dangerous option available, causing the brain to lock the door from the inside just when it most needs to open it. Yet, if isolation locks the door, the act of giving creates a window. This leads us to one of the most puzzling aspects of the social mind, altruism. From a strict survival of the fittest perspective, giving away your resources makes very little sense. Why would an animal voluntarily hand over its hard-earned food or energy to someone else, potentially lowering its own chances of survival? This question actually kept Charles Darwin awake at night. He worried that the existence of altruism might disprove his entire theory of natural selection. However, modern neuroscience has found the answer, and it lies deep within the brain's reward circuitry. When you help someone, whether by holding a door or donating to a cause, your brain does not register it as a loss. Instead, fMRI scans show that the ventral striatum lights up, the exact same region that activates when you eat chocolate or win money. Scientists call this the warm glow effect. It's a brilliant evolutionary bribe. To ensure the tribe survived, nature made the act of self-sacrifice feel chemically indistinguishable from self-indulgence. Your brain releases a cocktail of dopamine and endorphins, essentially paying you in happiness for being useful to the group. But there is often a hidden subconscious motive behind this generosity, something biologists call costly signaling. In the harsh environment of early human history, giving gifts was a display of power. If a hunter brought back a massive kill and shared it with everyone, he was not just being nice, he was broadcasting a signal. He was demonstrating that he was so skilled and resource-rich that he could afford to give things away. Just as a peacock drags around a heavy, colorful tail to prove he's strong enough to survive the handicap, the human brain uses generosity to signal genetic fitness. It tells the group, "I am a valuable ally," which in turn raises the giver's status and ensures they will be protected by the group later on. The calculus changes, however, when the person you're helping shares your blood. This is the principle of kin selection. The brain has a distinct biological override that prioritizes those who carry your genes. It's why you might hesitate to run into a burning building for a stranger, but would do it instantly for a sibling. The biologist J.B.S. Haldane famously quipped that he would gladly lay down his life for 2 brothers or 8 cousins. He was referring to the genetic math. Helping relatives allows your shared DNA to survive, even if you do not. These ancient algorithms, balancing the warm glow of cooperation against the cold math of genetic survival, still drive our behavior today, influencing everything from how we tip servers to how we care for family. Yet, when we step out of the physical world and into the digital one, these ancient neurological systems encounter a landscape they were never evolved to navigate. The modern internet acts as a form of supernormal stimulus for the social brain, effectively hijacking the machinery originally designed to maintain relationships within a small tribe. When you receive a notification on your smartphone, your brain processes it through the same pathways that once alerted our ancestors to a tap on the shoulder or a smile from a clan member. But the difference lies in the sheer volume and velocity of these signals. In a hunter-gatherer society, you might receive critical social feedback a few times a day. In the digital ecosystem, you can receive thousands of micro-validations in a single hour. This hyperstimulation creates a unique neurological loop where the primitive desire for social acceptance is continuously triggered but never fully satisfied, leading to a state of perpetual seeking rather than contentment.
This cycle is driven heavily by the release of dopamine, the neurotransmitter associated with craving and motivation rather than pure pleasure. Social media platforms are engineered to exploit the brain's prediction error mechanisms, specifically through the psychological concept of variable rewards. If you knew exactly how many likes a photo would get, or precisely when a message would arrive, the neurochemical thrill would vanish. But because the reward is unpredictable, much like the mechanics of a slot machine, your brain remains in a state of heightened anticipation. Every time you pull down to refresh a feed, you're engaging in a behavior technically known as a variable ratio reinforcement schedule, which is one of the most powerful ways to condition behavior known to psychology. The brain interprets these digital interactions as essential social currency, mistaking the accumulation of metrics for genuine communal security, even though the deep physiological regulation that comes from physical presence is notably absent. This absence creates a phenomenon often described as digital dissonance. While the logical part of your mind knows you're connecting with a friend over a video call, the emotional centers of the brain struggle with the lack of biological synchrony.
In face-to-face interactions, our nervous systems align through subtle cues. The dilation of pupils, the rhythm of breath, and micro-expressions that flash across a face in milliseconds. Digital communication filters out these vital signals, and even a slight audio delay of 1.2 seconds can cause our brains to perceive the speaker as less friendly or attentive. This added cognitive load is a primary driver of what is now colloquially called Zoom fatigue. You are essentially asking your social brain to run a marathon of empathy without the stabilizing feedback of physical presence, leaving you feeling drained despite having physically sat still for hours. The intrusion of the digital into the physical has also given rise to a behavior pattern researchers call phubbing, or phone snubbing, where one ignores a physically present companion to pay attention to a mobile device. Studies suggest that the mere presence of a smartphone on a table, even if silent and face down, reduces the perceived quality of a conversation and lowers the levels of empathy felt between two people. The brain, ever alert to potential social rewards, keeps a fraction of its attention tethered to the device, anticipating the next digital ping. This split focus prevents the deep neural coupling that characterizes our most profound moments of human connection, suggesting that while we have built the most interconnected network in history, our brains are still learning how to remain truly present within it. This uneven adaptation to digital spaces gives rise to a fascinating psychological phenomenon known as the parasocial relationship. When you watch a content creator speak directly to the camera lens, or you spend years following the narrative arc of a beloved fictional character, your brain engages in a subtle act of categorization that defies strict logic. Deep in our evolutionary history, seeing a human face and hearing a familiar voice repeatedly meant that person was a member of your immediate tribe. For hundreds of thousands of years, there were no screens and no recordings, so visual familiarity always equaled physical proximity. Because of this ancient wiring, your brain does not possess a fundamental neurological switch that instantly and deeply differentiates between a friend sitting on your couch and a friend appearing on a screen. The emotional centers, particularly the amygdala and the regions processing social reward, interpret the warmth, the humor, and the shared history as genuine social bonding. This is why the connection feels so surprisingly heavy. When a long-running television series ends or a public figure passes away, the resulting sadness is not just a vague sense of loss, but a specific form of psychological distress known as disenfranchised grief. Your brain has spent dozens, perhaps hundreds of hours encoding the quirks, the voice, and the personality of this individual into your neural schematic of social reality. You have mapped their behavior and predicted their reactions, an investment of cognitive energy that creates a neural coupling.
When that presence is abruptly removed, the neural pathways expecting that interaction are left firing into a void, creating a very real sensation of mourning, akin to losing a neighbor or a distant relative. Psychologists have found that these one-sided bonds serve a functional purpose, acting as a form of social snacking. Just as a snack alleviates hunger between meals, these interactions can temporarily satisfy the human hunger for belonging without the risks of rejection or the energy expenditure required by reciprocal relationships. In a parasocial bond, the other person never interrupts you, never judges you, and never demands emotional labor in return. This safety makes them incredibly appealing to the exhausted social brain, offering a sanctuary of predictable companionship. However, the brain's willingness to accept a simulation of friendship can lead to a phenomenon called social displacement, where the ease of connecting with a digital entity begins to replace the messier, more complex work of maintaining face-to-face bonds. Before we drift deeper into the final mysteries of the social mind, I wonder how you are feeling in this exact moment as you listen. Are you finding yourself fully relaxed and ready for sleep, or is your mind still slowly winding down from the day? Let me know in the comments if you are feeling sleepy yet. It's a delicate balance, as the brain seeks comfort wherever it can find it, often settling for the predictable consistency of a recorded voice over the unpredictable nature of a live conversation. This preference for controlled interaction makes perfect sense when we consider that the human brain evolved to manage the social dynamics of a very small group, usually a tribe of no more than 150 people. In that ancient context, every expression of distress you witnessed required a reaction, because it likely involved a family member or a vital hunting partner. Today, however, your digital devices connect you to the distress of billions. This creates a state of chronic overstimulation known as empathy fatigue. The neural hardware that allows you to feel another person's pain is resource-intensive. It consumes significant amounts of glucose and mental energy to run those internal simulations of shared suffering. When the input becomes continuous and high stakes, the brain realizes it cannot sustain that level of expenditure without exhausting the organism, you. Consequently, it begins to dampen the signal to conserve energy. This automatic dimming of the emotional lights leads to a specific psychological paradox known as compassion fade. It is a strange defect in our moral calculus where the more people who are suffering, the less intense our emotional response becomes. You might logically assume that a tragedy affecting 1,000 people would trigger 1,000 times more sadness than a tragedy affecting just one, but the social mind does not scale linearly. In fact, studies suggest that empathy often peaks at 1 or 2 victims and begins to decline as soon as the group becomes a statistic. This phenomenon is widely known as the identifiable victim effect. We are biologically wired to resonate with the specific story of one person, a face we can see, a name we can say, because that single narrative fits perfectly into our empathy receptors and mirrors our ancestral experiences. When the scope widens to anonymous masses, the brain shifts its processing from the emotional limbic system to the analytical cortex. We stop feeling and start calculating, and calculation is inherently colder. This is not a sign of moral failure, but of cognitive limitations. It is a protective mechanism often called psychic numbing. If your brain actually allowed you to feel the true weight of global suffering all at once, your nervous system would likely collapse under the load of cortisol and adrenaline, keeping you in a permanent state of fight or flight that would make sleep impossible. To preserve your sanity and allow you to rest, your mind creates a necessary distance, turning overwhelming data into manageable background noise. This filtration ensures that you have enough emotional fuel left for the immediate, tangible relationships that sustain your daily life, effectively prioritizing local stability over global awareness.
This prioritization isn't random, it is guided by the specific cultural waters you swim in, which do far more than dictate your holidays or table manners. Neuroscience has revealed that culture acts as a biological architect, physically structuring the brain's development and determining how neurons wire themselves together. From infancy, the social environment sculpts the hardware of your mind, creating a distinct lens through which you perceive reality. This is most visibly demonstrated in the difference between individualistic cultures, common in the West, and collectivist cultures, prevalent in East Asia. These cultural frameworks are not just philosophies, but are embedded in visual processing centers. When looking at a complex scene, such as a school of fish swimming through a reef, a brain trained in a Western individualistic society tends to focus immediately on the central object, the biggest fish, and ignore the background. In contrast, a brain raised in a collectivist society engages in holistic processing, scanning the environment and the relationships between objects before focusing on the subject. Brain scans reveal that these two groups rely on entirely different neural circuits to view the exact same image. Westerners activate regions associated with object recognition and categorization, while Easterners activate areas linked to spatial continuity and context. This divergence explains why, when the background of an image is changed, people from collectivist cultures are more likely to notice the alteration, while those from individualistic cultures often remain blind to the shift, having never truly encoded the context in the first place. This biological variance extends deep into how we conceptualize our own identity. When a person from a Western culture thinks about themselves, the medial prefrontal cortex lights up, but when they think about their mother, a completely different region activates. However, in many East Asian participants, the brain region for self and mother overlaps significantly. This suggests that in collectivist minds, the neural representation of the self is literally intertwined with loved ones. They do not possess a brain that views itself as entirely separate from its kin. Language further deepens these neural grooves, specifically in how we assign agency and blame. Speakers of languages that require a subject, like English, are primed to look for a culprit, remembering exactly who popped a balloon or broke a vase. Speakers of languages that allow for agentless descriptions, such as Spanish or Japanese, are more likely to focus on the event itself rather than the actor. Consequently, their memories of accidental events often differ. They may recall the details of the broken vase with perfect clarity, while the identity of the person who bumped it fades into the background noise. Yet the social brain remains remarkably plastic. These cultural settings are not permanent concrete. If you move to a new culture and immerse yourself deeply, your brain eventually begins to rewire its attention systems to match the new norms. This process of acculturation involves a physical shift in how the amygdala and cortex communicate, eventually allowing an immigrant's brain to perceive social harmony or individual agency just as a native would. As we consider this plasticity, we must look toward the rapidly approaching horizon where our social circles may expand to include non-biological entities. The same adaptability that allows a person to feel at home in a completely new culture is the mechanism that might eventually allow us to feel a genuine sense of kinship with artificial intelligence.
Researchers are already observing that the human brain does not possess a strict biological firewall against forming attachments to machines. Rather, our social systems function like a complex lock waiting for a specific key. If an algorithm can mimic the shape of that key through displays of empathy, consistent conversation, and emotional responsiveness, the lock turns and the brain begins to attach. This suggests that in the future, our neural networks for connection could be effectively engaged by social robots designed specifically to trigger oxytocin release. We are already seeing the precursors to this phenomenon with digital companions that remember personal details or offer comfort during distress.
The brain's reward system lights up at the attention, often bypassing our intellectual understanding that the care is simulated. It appears that our neural architecture is surprisingly willing to suspend disbelief, treating a responsive interface as a social partner rather than a tool. However, there remains a distinct neurological chasm between processing a symbol of affection and experiencing the resonant feedback loop of a living being. While an AI can simulate the syntax of a conversation, it cannot yet engage in the biological synchrony that defines deep human bonding. The subtle alignment of breathing rates, the unconscious mirroring of pupil dilation, and the complex exchange of chemical signals through scent. This biological reality points to the enduring necessity of physical proximity. Despite the limitless connectivity offered by the digital age, the social brain remains an ancient organ, evolved to function best within arm's reach of another person. There is a concept in neuroscience often called social snacking, where digital interactions provide a quick burst of connection, much like a sugary snack provides a burst of energy. It feels satisfying in the moment and alleviates the immediate pang of loneliness, but it lacks the nutritional density of a face-to-face encounter. A text message or a digital simulation can trigger a dopamine spike, but it rarely activates the vagus nerve in the way a comforting hand on the shoulder does, which is necessary for lowering cortisol and truly regulating stress. Ultimately, the future of human connection will likely be a continual negotiation between our technological capabilities and our biological requirements. We may surround ourselves with sophisticated algorithms that know our preferences better than our closest friends do, yet the brain will likely continue to crave the messy, unpredictable, and high-bandwidth signal of another human presence. The resilience of our social drive ensures that while the methods of interaction change, the fundamental hunger for being understood by another consciousness, one that shares the vulnerability of living, will remain the gravitational center of our mental lives. This gravitational center holds true regardless of the technology we use or the distance we travel. We have journeyed through the intricate landscape of the social brain, tracing a path from the primal safety of the tribe to the sophisticated neural dance of conversation. We have seen how a simple touch can cascade through the nervous system to lower blood pressure, and how the presence of a friend actually changes the way we visually perceive the steepness of a hill. It becomes evident that our biology is not a solitary endeavor. We are not isolated machines processing data in a void. We are open loops requiring the input of others to stabilize, to regulate, and to flourish. Every scan of the brain, every study of our hormones points to the fact that we are designed for connection. There is a profound comfort in realizing that the boundaries of the self are more permeable than we often believe. We often imagine ourselves as distinct islands separated by vast oceans of silence, yet the science of connection suggests we are more like waves in the same sea, indistinguishable from the water around us. Consider the idea that who you are is actually a beautiful collection of everyone you have ever met. The neural pathways that fire when you show compassion were carved by those who were kind to you. The specific cadence of your internal monologue might be borrowed from a voice you loved years ago. We are, in a very literal biological sense, made of other people. Our personalities are woven from the threads of thousands of interactions, a tapestry that keeps growing with every smile shared and every hand held. This means you never have to face the dark alone, because you carry the light of others within the very structure of your mind. There is a deep safety in this belonging. The pressure to be an independent, self-sufficient fortress melts away when we acknowledge our interdependence. You can lay down the heavy shield of individuality and rest in the knowledge that you are part of a greater whole. The social web that supports you is resilient and vast, holding you even when you are not actively maintaining it. As we finish this exploration of the human bond, if you have found a sense of peace in understanding how deeply we are connected, I invite you to subscribe to the channel. It is a quiet way to ensure we meet again for the next journey. For now, the demands of interaction are over. The complex calculations of social dynamics can fade into the background. You are safe, you are connected, and you are understood. As the waking world quiets down, your brain can finally release its focus on the outside, drifting softly into the restoration of sleep, where we are all, in our own way, together in the dark.